Hi, my name is John Hinsey, and the national park that I chose to research on is the Great Basin National Park in Nevada. So just an overview of what this national park is. It is based near the second tallest mountain in the state of Nevada, Wheeler Peak. There's a bunch of mountains that protect 5,000-year-old the limestone Lehman Caves, rock glaciers, and bristlecone pines. And overall, there's just a chain of peaks and mountains as well as valleys. And yes, all three types of rocks do exist in this park: igneous, sedimentary, and metamorphic. And for the Precambrian, the basin mostly formed because of diverging continental crust. And then up to the early and middle Paleozoic era, eras, that's when the sedimentation occurred continentally. And then in between the Paleozoic and the Mesozoic era, there was thrusting that was occurring within the basin, which is when the plates were starting to overlap with each other. And then during the Tertiary era, there was volcanoes that were altering the land. There was a chain of volcanoes, and it left behind volcanic rocks as well. And then up to the Pleistocene, there was a large presence of water overall as well. There was a lot of water, and that impacted the overall topography of the national park. And then, last but not least, overall, the Cenozoic era, the Wheeler Peak was glaciated, especially during the ice ages, and it left a mark on the peak overall. So when it comes to the tectonic setting, basically what happened is that the basin was formed by stretching forces through faults, and that's what caused the mountains and valleys. And there was hanging walls and footwalls, and that's how it was forming through faults. And then the mountain ranges are like oriented north to south. And that's kind of along where the divide is. As you can see, there's regions with a lot of granite here, JG, KGR, and TJR, and that's just where most of the igneous rocks are. And then the metamorphosed mountain ranges, this is where the biggest mountain is. It's full of quartzite. This is CZBPM, and that's near this pink area. And then all the way down south to the granite peak, this is where the dolomites are, and that's OSFL. And then limestone, even more down south, limestone is present in the North Peak in OCN. When it comes to the metamorphic rocks, the national park has quartzite, gneiss, schist, and some low-grade marble that was metamorphosed. So on the right is the Jeff Davis Peak, which is that peak is mainly made out of quartzite, and it comes from sandstone that was metamorphosed. There's also a metamorphosed limestone that turned into low-grade marble as well. Now for the geologic structures overall, the most prominent geologic structure would have to be the Southern Snake Range declement overall, and it's mainly low angle. There's not much of a change in elevation overall, and there's visible plutons near the range by where it's subducting, which is the Pacific plate is basically going under the North American plate. The sedimentary rock, there is limestone, shale, and conglomerate. The Notch Peak is an example of limestone existing. They have clastic sedimentary rock. On the right, there's a picture of it with limestone, and you can see the layers. This was mechanically weathered during the Precambrian. So with the depositional environments, this is more of a continental deposition environment, and basically lithification occurs when the sediment is deposited. And in the park, there's several instances of alluvials, so this just further proves that it's more of a continental depositional environment. Now with the igneous rocks, granite is the main igneous intrusion that occurs in this park. It occurs with JG, KGR, and TJR regions. And it was mainly formed by a chain of mountains that made magma chambers. And these magma chambers ended up exposing granitic plutons across the park. So when it comes to the volcanic activity, there is volcanic tuff, which is made up of plagioclase feldspar, hornblende, and biotite, as well as rhyolite. There is, in the TMP to the right, as you can see from the map, there are dikes and sills that appear here. And there is no volcanic glass or no obsidian, but there is another range with volcanic tuff that's interlayered with conglomerate, and that's in the Needles Range, titled T and R. But when it comes to the topography, it's full of mountains and peaks, and overall there's a big change in elevation throughout the whole park. And I searched. It was kind of hard to find a topographic map, so it was in meters, but I was able to convert it to feet. The contour interval was 50 meters, and it is shown that Wheeler Peak is the highest elevation with 13,063 feet, and then the lowest elevation is the Lehman Caves at 6,825 feet, so it's about a 7,000 feet difference. And as well, you can tell from the elevation profile that it is pretty tall when it comes to the whole park. I took the elevation profile from Wheeler Peak to the Lehman Cave, so the highest to the lowest peak, from east to west. And there's also Baker Peak, and Pyramid Peak, which are the most right here and here, where they're pretty tall compared to the rest of the land. And you can see that there's like flat lands around it, and especially near where the Lehman Caves are. So it seems it's just full of valleys and mountains overall, just flat and then high. With the rivers and streams, there are several streams that go through this national park. There's the Strawberry, Mill, Lehman, Baker, Snake, South, Fork, Big Wash, Shingle, Pine, Ridge, and Williams. These streams either flow towards Snake Valley, Spring Valley, or the Bonneville Basin, and these rivers overall cause erosion to the land. And the picture right here is of the Strawberry Creek. So some glacial features. There are Cirque rock glaciers that are formed in Wheeler Peak. Like I mentioned before, they were formed mainly during the Ice Age as well, but they've continued to form these rock glaciers, as you can see from the first picture. And there are also marked by terminal and lateral moraines. This is surprisingly the only glacier that really appears in Nevada overall. So now for the desert, this is considered a cold desert. Even though it has low precipitation, it's 10 inches per year, it doesn't ever rain. It's mostly just snow. And there is a presence of sagebrush and bristlecone pine that are abundant throughout the desert overall. And there's a lot of alluvium that's on the floor of the desert. And that's all that I have. Thank you for listening.